Hello, CP Pre-Calculus. We are now on day 2 of online learning. So hopefully everything went well with yesterday's lesson, and I did notice that the majority of you did extremely well on your WebAssign. But if there are any additional questions on that, please come to my Canvas conference today and ask if you have any difficulty with the concepts that are covered. I can also take a picture of my notes and post them from yesterday so that you can, take a look at a hard copy of them. Now today what we're going to do is actually take what we went over yesterday with the factoring in today's video, and we are going to also use that to help us verify trig functions. Now for everybody should have this cheat sheet. You should all have this cheat sheet, right? And if you don't have this cheat sheet, I'm posting a copy of this cheat sheet. If you look above, there's a posted copy of your trig identity cheat sheet. And these are the trig identities that we're going to use when we are verifying our identities. So these again are our basic trig identities. So when you get this sheet, we have our basic trig identities. And if you look at the notes that have been posted from this chapter already, these are all listed, but down here we have some of the manipulated Pythagorean identities to help us out. All right, so these are our basic trig identities. So I'm going to have that sheet here so we can reference it. All right, so now what we're going to do today is we are going to continue to verify identities, but I'm going to do an example. So we're going to verify our trig identity. And let's remember from our previous notes, and if you take a look, if you weren't there, the notes are posted from last week. When we verify our trig identities, we have a couple rules. Number one, we're going to only work with one side. And number two, you cannot move anything from one side to the other. So those are the two important rules that we need to follow when we verify our trig identities. So those are my important rules. All right, guys? So what I'm going to do is I'm going to just review an example problem right now. And it kind of uses the factoring that we went over yesterday. So in this example, I am going to have sine squared theta plus 2 sine theta plus 1 all over cosine squared theta. And I want to verify that it's equal to 1 plus sine theta over 1 minus sine theta. That's what I want to verify. Now, we just said that we can only work with one side. So that was one of our first rules. You can only work with one side. And that being said, I usually pick a side. In this side, I like to draw that line so I know I can only work with one side and I cannot move anything from one side to the other. Meaning, if I draw this line here and I'm working on the left, I am going to ignore the right. And I'm going to manipulate the left side of my equations, my trig identity, using my basic identities to look like the right side. Now, after yesterday's lesson, we would notice that our numerator on the left is the form quadratic form, meaning sine theta is being squared, then I have a sine theta, and I have a 1. And if I have a trig expression in quadratic form, I'm able to factor it. Now, I look here, my leading coefficient is 1. Therefore, I can use my basic factoring method and say what adds to 2 and multiplies to 1. So I'm saying to myself what adds to 2 and multiplies to 1. And in this case, I'm lucky, it's fortunate, it's just 1 and 1. So instead of factoring to have x plus 1, because I have sine theta squared, I'm going to have sine theta plus 1 and sine theta plus 1. So I was able to factor the numerator. Now I'm looking at that denominator, and I'm saying to myself, I have a cosine squared. But when I look at the right side and I say, I need to get my expression with only a sign. I need to somehow rewrite that cosine squared theta. Go to your cheat sheet. If I look at my cheat sheet, right here on my cheat sheet, right there it says cosine squared is equivalent to 1 minus sine squared. So therefore, I can substitute that 1 minus sine squared in for cosine squared. So I'm getting sine theta plus 1 times sine theta plus 1 all over 1 minus sine squared theta. All right. Now I have my expression with only signs. So that is what I wanted. So now my goal is to simplify. Now again, look at this bottom. Look at that denominator there. And we went over in class, if you have 1 minus sine squared, this is the same as our difference of two squares, which we also reviewed yesterday on our online video. And if I look at this, this is 1 being squared, and that's sine being squared, sine theta. So I can rewrite this as sine theta plus 1, sine theta plus 1, and then the denominator can be 1 plus sine theta and 1 minus sine theta. So I was able to factor this denominator because we had the difference of two squares, 1 squared and sine theta squared. Now if we take a look at this, sine theta plus 1 and 1 plus sine theta are the same exact thing. So I can cross one of them out. And by me crossing one of them out, I have sine theta plus 1 and 1 minus sine theta. Now the only difference here is that in my numerator up here, I want the 1 first. So I can rewrite this to have 1 plus sine theta all over, because the order doesn't matter, 1 minus sine theta. And I now verified my trig identity because I have the same thing on the left that I did on the right. And I followed my rules. I only worked with one side, and I didn't move anything from one side to the other. And my trig identity was verified. Now to review more on verifying trig identities, you actually have puzzles today as your activity. So you are given 4 trig identities, and they're labeled in your puzzles 1, 2, 3, 4, and they're stated as the starting points. Then you have all these puzzle pieces. So I need you to cut out all the puzzle pieces of your trig identity puzzles when you print it out or writing it out. And I then need to use every single piece of that puzzle to verify the 4 trig identities that I gave you. And in the process, you will be using our basic trig identities that we've learned in class and the rules of simplifying trig identities that we learned in class to help you verify those 4 problems. When you're done verifying those 4 problems, I need you to take a picture of your finished puzzles. There should be 4 of them. And send it to me through Canvas. If you have any questions, please come to office hours and I will answer them for you. All right, so hopefully we're okay with our basic trig identities and how the method we use to verify trig identities. All right, I will talk to you later at office hours. Have a good day.